In this class, I will explain a problem on ladder friction. It is a VTU question paper problem, January 2019. The problem states like this: a ladder 4 meters long and weighing 200 Newton is placed against a vertical wall and rests on a horizontal floor at an angle of 60 degrees with the floor. Coefficient of friction between ladder and floor mu f is 0.3 and coefficient of friction between ladder and wall mu w is 0.2. The ladder supports a man weighing 600 Newton at a distance of 3 meters from the floor along the ladder. Find the minimum force P to be applied horizontally at the floor level on the ladder to keep it in equilibrium. So this is the problem. So figure we have to draw. He has given this statement. This ladder, which is having 4 meters length and weighing 200 Newton, it is kept against a vertical wall and a horizontal floor like this. This is the horizontal floor, this is the vertical wall. Both being rough surfaces, contact surfaces or rough surfaces, because they have given mu values for both floor and wall. So the inclination of the ladder, this is the ladder, the inclination of the ladder with the floor is 60 degrees. That's what he has given. Let me take this AB as the ladder. The weight of the ladder is 200 Newton. You know that the weight of the ladder acts at the center of gravity of the ladder, G. So this is 200 Newton. It acts vertically downwards. So length of the ladder being 4 meters. So definitely this G will be at 2 meters. Center of gravity will be at the midpoint of the ladder, centroid of the ladder. So that is 2 meters from the floor. Now he has given that the coefficient, a man is standing at a distance of 3 meters from the floor along the ladder. So along the ladder means like this. So 3 meters means it will be here. I will take this point as C. A man is standing at a distance of 3 meters from A. So the weight of that man is given as 600 Newton. That is like this. Now the question is, what is the minimum force P to be applied horizontally at the floor level? That means at the bottom on the ladder to keep it in equilibrium. So the tendency of the ladder is to slip down like this. So the motion of the ladder will be like this along the wall. And since it slips down like this, naturally it moves to the right along the floor. So the motion of the ladder along the floor is towards right. So definitely you will be having frictional forces acting in the opposite direction of the motion of ladder. So here along the floor, frictional force will be acting like this, opposite to that of the direction of motion. So I will call it as Fw. So Fw is the frictional force existing between the wall and the ladder at this contact point B. And along the floor, since the direction of motion of the ladder is like this, frictional force will act in the opposite direction, Ff. Ff is the frictional force acting at the contact surface of the ladder and the floor in the opposite direction of the motion. And you have normal reaction also that is going to develop at this point A. So normal reaction will be like this. I will take it as NF. The NF is the normal reaction at the floor. And here normal reaction at the wall, I am going to take like this at B, NW. So NW is the normal reaction at the wall. Now these are the things. Now the question here is, since the ladder tries to slip down along the wall and it tries to move towards right along the floor, we have to apply a force P horizontally at the floor level. So this is the floor level. At the point P, at the point A, we have to apply a force P like this, horizontal force P, just to avoid the slipping of the ladder. So the tendency of the ladder is to slip down and move towards right here. Since the movement of the ladder has to be avoided, the force to be applied should act in the direction opposite to the direction of the motion. So So like this. So we have to find this minimum value of P that is required to avoid the slipping of ladder, or in other words, that is required to keep the ladder in equilibrium. Now this is the diagram, and you can see that if you write the free body diagram of the ladder, you will be having set of forces. All the forces are coplanar non-concurrent forces. So to analyze problems of equilibrium of coplanar non-concurrent forces, we have to use three equilibrium equations: sigma fx0, sigma fy0, and sigma ma0. So this constitutes coplanar non-concurrent force system, non-concurrent forces, because the lines of action of the forces, they are not meeting at a common point. So we have to use three equations of equilibrium. One is sigma fx0. We can use force acting towards right positive, left negative. Second one is sigma fy0, forces acting upward positive, downward negative. Third one is sigma ma0 or mb0. Algebraic sum of all the moments of all the forces taken about the point A and equal to 0. You can take clockwise positive and anti-clockwise negative. So using these three equilibrium equations, you can solve for three unknowns. Actually, the three unknowns here, they are NF, NW and P. So these are the three unknowns, because you know the relation according to the law of friction. Ff is equal to mu f into Nf, and Fw is equal to mu w into Nw. Now here the values of mu f and mu w are given here. Mu f is 0.3, so Ff is 0.3 times Nf, whereas mu w is 0.2, so therefore Fw is 0.2 times Nw. So once you get the value of Nf and Nw, you can find out the values of Ff and Fw, and the other things you can always obtain. That means here, after applying the three equilibrium equations, you can get these three values. So finally we are interested in the value of P. What is the minimum force P that should be applied to keep the ladder in equilibrium? Now let us write down the free body diagram of the ladder. So before that, you can see here in this right angle triangle, this is a right angle triangle, since you need to find the moments, in order to use the third equilibrium equation, to calculate the moment, you need the distances of the lines of action of the forces from the point A. For that, what I do here is, first let me calculate the distances now. So the first right angle triangle I will take, this AB is the ladder. So this is 4 meters. Length of the ladder is 4 meters. You can see here, that is given, and this angle is 60 degrees. Once you know the angle and hypotenuse, then you can find out the other two sides. So this side, you can see this side will be 4 sin 60, because it is opposite side, and this will be 4 cos 60. Similarly, if I take the second triangle like this is a smaller one. So we have this second triangle as CA, I will take. The distance here is 3 meters. So here also, this is 60 degrees, angle remains same. This becomes 3 sin 60, opposite side 3 cos 60. And the third triangle is a smaller one, which is nothing but GA. Once again, this distance is 2 meters. This one. So here this becomes 2 cos 60, this becomes 2 sin 60. Now once you know these these distances are very much required because we have to calculate the moments. So you can see here this at C you have a downward force, that is weight of the person, 600 Newton is acting, and at G you can see that weight of ladder is acting, that is 200 Newton vertically downwards, and at B you can see here, at B you have two forces acting. One is the normal reaction NW, Another one is the frictional force FW. So these two are acting at B. So once you note down the distances and what are the forces that are acting at the respective points, you can easily calculate the moments. Now let us apply one by one the three equilibrium equations. So what I do here is, first I am going to use sigma Fx is equal to 0. Sign convention is force acting towards right positive, left negative. If you see the diagram here, so towards right forces are this NW is acting towards right, so it is positive. Then coming over here, FF is acting towards left, so it becomes minus FF. Then this P is also acting towards left, minus P. So P should be applied in the direction opposite to the direction of motion of the ladder. That you should note down. Here this equation can be written as NW minus FW can be written as, FF can be written as, I have written here 0.3 times NF. Because FF is mu F NF, mu F is given as 0.3, so 0.3 times NF minus P is equal to 0. So this is the first equation you can get from the first equilibrium equation. Second equilibrium equation is sigma Fy 0 for the entire system. Upward forces positive, downward forces negative. Once again, if you observe the system of forces here, Fw is acting upwards, so it is Fw is positive. NF is also acting upwards, so plus NF. But the 600 Newton and 200 Newton, they are acting downwards. So minus 600 minus 200 is equal to 0. Or you can write Fw can be written as 0.2 times Nw. So 0.2 times Nw plus Nf is equal to 800. So this is the second equation you can get from the second equilibrium condition. Now the third equation is the moment equation. Algebraic sum of the moments of all the forces taken about the point A equal to 0. Taking clockwise moments positive, anti-clockwise moments negative. Here you should be careful because moment is nothing but the force multiplied by the corresponding distance to the line of action of the force from the point A. So now I have to consider one by one. I will take this NW force. This NW force is acting, it is giving a clockwise moment about the point A, and the distance of NW force is this distance, that is nothing but 4 sin 60. So I can write as since it is clockwise, so NW into 4 sin 60. So this is the moment due to NW about the point A. Next FW. FW is also giving a clockwise moment about the point A, plus FW I can write as 0.3 times NW. Okay, 0.3 times NW multiplied by this distance. So for vertical force distance is horizontal, for horizontal force distance is vertical. So horizontal distance here is 4 cos 60 into 4 cos 60. So this is the moment due to FW force. Next, come to this 600. The 600 Newton is acting at a distance of this, you can see 3 cos 60. I have written here. So it is giving an anti-clockwise moment about A. So minus 600 into 3 cos 60. That is the moment. Next, coming to this 200 Newton force, this is also giving an anti-clockwise moment about A. Distance is 2 cos 60. So minus 200 into 2 cos 60. So now 1, 2, 3, 4 forces are over. See this FF force, NF force and this P force, all these three are acting at the point A only. The lines of action are passing through point A only. Therefore, the moments due to all three forces will be 0. So you need not consider that. So therefore, is equal to 0. So this is the expression for this is the moment equation. Now, if you simplify this, you can get the value of NW. Now let us simplify this. the equation becomes now 4 sin 60 into NW, that is 4 into sin 60 is 3.464 NW plus 0.3 into 4 into cos 60, which is 0.6 NW, then minus 600 into 3 into cos 60, 600 into 3 is 1800 into cos 60 is half, so that becomes 900. Then here 200 into 2 cos 60 is half, so 200 into 1, so it becomes minus 200 is equal to 0. Now from this you can easily get the value of NW. So let us see what is the value of NW here. So when you bring it to this side, it becomes 1100 divided by this plus this. So that plus this becomes 4.064. So 270.67 newtons. So since the weight of ladder and weight of the person is given in newtons, the answers of reactions also will be in newtons. So NW value is 270.6967 newtons. Now once you get this, now back substitution we have to do. Substitute this NW value in equation 1, in equation 2, you will get NF value. Then you substitute both the values of NF and NW in equation 1, you will get the P value. So back substitution method we have to follow now. So now what I do here is substituting for NW in equation 2. So substituting for NW in equation 2, you can get the value of NF. So NF is equal to, from equation 2, 800 minus 0.2 times NW, that is 800 minus 0.2 times 270.67. Now if you simplify this, so 800 minus 0.2 into 270.67, which is 745.87. 745.87 newtons. So this also will be newtons. That is the value of NF. So once you get the value of NF, so both NF and NW are known. Substitute in equation 1, we will get the value of P. So substituting for NW and NF in equation 1, you will get the value of P as P is equal to NW minus 0.3 times NF, which is NW is 270.67 minus 0.3 times NF is 745.87. Now if you simplify this, you will get the value of P in newtons, which is the minimum force to be applied to keep the ladder in equilibrium or to avoid slipping of ladder. 270.67 minus 0.3 into 745.87, it comes out to be 46.91 newtons. That is the minimum force that has to be applied on the ladder to keep the ladder in equilibrium. So that means in this problem there are so many parameters here. You can see in a ladder problem, so there will be so many parameters, and among those parameters some of them will be known, some of them will not be known. So only 3 unknowns can be found out, because we can maximum number of equilibrium equations we can apply in the problem of ladder friction is 3, because it is nothing but coplanar non-concurrent force system. So here the parameters in the case of a ladder friction are, so you can see here, I can list out the parameters here. So the mu F, mu W, coefficient of friction between ladder and floor, coefficient of friction between ladder and wall. Suppose if they give smooth wall if they give, then the value of mu w you have to take it as 0. When mu w is 0, Fw will be 0 because Fw is mu w into Nw. Nw will be having some value. Nw will not be 0 because it becomes a smooth surface. In the case of a smooth contact surface, you have only one normal reaction. Friction reaction will not be there. Suppose if they give smooth floor, then the value of mu f will be 0, or in other words, Ff will be 0 because Ff is mu f into Nf. So since mu f is 0, Ff will be 0, but Nf will not be 0. Please make a note of that. Even though friction force is 0, normal reaction will not be 0. Even the coefficient is mu is 0. So now this is one thing. Then sometimes they may ask you to find this horizontal force, minimum horizontal force P to avoid switching of ladder. That is also a parameter. Then coming to this NW, NF, Fw, Ff. So these are the parameters. I am listing what are the parameters involved in this type of problem. Of course, here there is a relationship between these things. NW is mu w into Fw is mu w into Nw, Ff is mu f into Nf. So these two are already known. Therefore, among these totally you have 6 here. Out of 6, only 4 if you find out. The other 2 you can find out easily. So that means you can avoid any 2. So finally it becomes 5 here. Then among that, then you have this weight of ladder. Weight of ladder is also a parameter. Then weight of person. Weight of person is also a parameter. So these are all the things. Length of ladder. So all these things are parameters. So among this, what I mean to say here is, finally you should have only 3 unknowns. Then only the problem becomes a determinate problem. You can solve or analyze the problem using only the equations of equilibrium. So what I suggest you is, understand the problem correctly, write down the diagram, list out what are the data given in the problem. Only 3 unknowns should be there. So in this problem, of course, NW, NF and P, they are the unknowns because mu f and mu w they are known. Ff and Fw can be found out once we get the values of Nw and Nf. So that means finally only 3 unknowns can be evaluated using the 3 equilibrium equations in the case of a ladder friction, whereas in the case of a block friction problem we have seen already in the earlier classes, only 2 equilibrium equations we are going to use, sigma Fx0 and sigma m0, because the forces in the case of a block friction problem, connected bodies problem, it gets converted to a coplanar concurrent force system wherein moment equation won't come into picture.